proportion the same, and then it's also asking how much water you would need. You just subtract. You figure out the milliliters of dye, and then whatever's left over is obviously going to be the water. Okay?
That part's easy.
That's the easy part. Okay, now specific. So, that's just a basic ratio. This is giving you more specific if you're talking about weights, if you know your final volume, you're talking about specific concentration. So this isn't like, before, like I said, it's a ratio, 1 to 10 or whatever to whatever. This is actual specific concentration you're trying to achieve. So how would you do that? So I actually like, I think the handout shows it, explains it a little bit better. Where are we?
Right there.
Okay. So like I said, so there, you're going to have instances where you need to prepare a solution with a specific concentration. So like I said, the ratio is just 1 to 10, what your ratio is going to be. This is going to be, you want a specific, you're trying to achieve a specific concentration. So V1 is the volume of stock solution needed to make the new solution. So we're trying to make a new solution. So what's the volume of stock solution that's needed? That's V1. C1 is the concentration of the stock solution. This will make sense when we start talking about it in a second. V2 is the final volume, so what are you trying to reach? And then the final concentration. So C stands for concentration, V stands for volume. So when you're looking at an example, I think we have the same example in here. So you've been asked to prepare 500 milliliters of a 0.1 molar hydrochloric acid solution in the lab. In the solution. In the lab, you need to have 12 moles of 100 milliliter stock. So what you've been asked to prepare 500 milliliters of a 0.1 molar solution, but what you have on hand is 12 moles of 100 milliliter stock. So how much do you need? How much of the stock do you need? So if you have 12 moles and we only need 0.1 moles, how much of that 12 mole solution that you have do you need to make 500 milliliters of a 0.1 molar solution? We got that? What the question's asking? We understand what the question's asking? Okay, so how much of the 12 molar stock will we need? So remember, C is concentration, V is volume. So anytime you're talking, anything that's molar is going to be your C value, but now you have to know which one it's talking about. Again, looking at that handout. So C1 is concentration of stock solution, and then C2 is the final concentration of the solution desired. So do we know what the concentration of the stock solution is? Yes, right? It's 12 moles. That's what we have. Do we know the volume of the stock solution needed to make the new solution?
No.
Right, so do we know the volume of what we need? So we know the concentration of the stock solution.
Well, 500
So the stock
ml
solution
is the new
we have is
volume.
12 mole, right?
So 500 ml is the new volume that we need, right?
That's the new volume. No, the new volume. So again,
We know our
that's what we
desired
want.
volume. We know our desired volume, but we're
Right,
We don't know the
we'll
volume.
need to
right.
start off.
So V1, also these two backwards.
You
Yeah.
should put the values in C1 and V1.
No, it says V1, the amount of needed stock solution. And doesn't it say to prepare 500 milliliters?
V1 is the volume. V1 is the volume of stock solution needed to make the new solution.
We
So
don't have that.
We don't know.
We don't
right.
have that. But we have the rest.
V1 is how, because that's what the question is asking. So V1, let's do it this way. Can you see it if I do it this way?
Issue.
I'm so
We have all
confused.
of them, but V1. We have.
Right, but I'm trying to make sure that everyone understands like what,
I think everyone,
does everyone have a handout?
yeah.
I don't, that's why.